Thank you.
Okay. Got to click it. Yes. Got to click. Thank you very much for inviting me. I invited myself, but I offered to do it really, so it's fine. Good evening all, and good evening to those online. My talk is going to describe briefly the history of the Washwood Heath site and depot. Somebody's on call. I've got to go. From its inception to the present day, upcoming as its upcoming use as the rolling stock maintenance depot for HS2. I'm sure a lot of people around this table know about Washwood Heath, and I'm not going to tread on their toes if I don't say what they want to know. But I will outline the general changes made since 1877, when and then describe the proposals for the HS2 depot up to the decision to locate a depot at Washwood Heath. The HS2 related part of my talk will look at track rolling stock systems and the general architecture of the site and different buildings and what's going on the site. The materials for my presentation, I'll be pleased to know, was approved this morning by HS2. So it's a good job they did do it this morning. It's been sourced by freely available information, to be honest, online documents, including the recently published Schedule 17 plans, which were published at the end of last year. Also, I've used a lot of HM government documents for HS2 and Wikipedia sites and sources. And also, I'm grateful to HS2 for allowing me to present it, but also I've used a lot of sources from the Midland Record and from Warwickshire Railways sites. Okay. So we'll talk about pre-HS2, before HS2 came along. So Washwood Heath sidings, this shows the west end of the sidings in around 1886, but they were found basically between Bromford Bridge Station, which is to the right on this slide, and Saltley Station, which is to the left on this slide, on the Birmingham to Derby line. Birmingham's to the left, for those who don't know their geography, and Derby is to the right. The sidings were located at Washwood Heath because the site offered a number of considerable advantages to the Midland Railway, who required a facility near Birmingham on the main Derby to Bristol line. Very near the centre of Birmingham. There was a level and greenfield site at the time, and was also close to the London North Western and GWR routes to facilitate easier exchange of traffic to major conurbations in the country. The layout of the sidings was very complex and will be seen in later slides. This is an early slide. It was first opened by the Midland Railway to serve their needs in the Birmingham area in October 1877. And initially, the Midland provided the sidings on the down Derby to Birmingham line. The down line, which gets me very confused, the down line is a line towards Birmingham, from Derby to Birmingham.
Yes, up to Derby.
Up to Derby, which got me very confused. So Derby was presumably much busier than Birmingham at the time. Okay, the slide shows the West End in 1886. Now note the connection to the line that's going north-south, the Stetchford-Ashton line, Stetchford-Ashton line, that's right, the SAS, which is the curved line curving down to the right. This is the line at the east end. So you can see there's just a very few sidings, not very many sidings at the east end, and nothing to the north of the Midland Railway. Come 1900, the hump yards were opened in 1900, and with most lines being commissioned in September of that year. And in the early days, the sidings were clustered around the down lines, as I say, those going towards Birmingham. The hump yards survived until the early 1980s. This slide shows the east end around 1903, so there's quite a few extra, two extra siding fans and a few extra lines in there. And this siding shows the west end at the same time. So not a lot of difference, but you can see there's some carriage works that have been added on the north of the line, and the Stetchford line is still there. Yeah, okay. This diagram, 1913, shows the plethora of tracks and sidings, including the Washwood Heath down sidings, which is just the top right-hand corner. I haven't got a pointer, I'm afraid, but top right-hand corner. You can see on this, just up here, the sidings, Can't see it on the. There's an awful lot of railway. You can see where the railway goes into Curzon Street Goods and into New Street Station. Curzon Street is where the latest HS2 station is going to be. So this is a single line diagram, which is the opposite way round to the other diagram. I managed to get this diagram, but unfortunately it's shown back to front, unfortunately. So the upsidings are the east is to the left and west is to the right. So didn't want to turn it upside down. But this basically shows the how much expansion had been done up to about 1935. Further expansion outward bound from Birmingham and the immediate locality caused the MR to establish sidings on the up Birmingham to Derby line in January 1918. And the growth of light engineering saw the region escape the worst excesses of 1930 slump, and further traffic was still being generated. This increase required the up sidings to be enlarged in 1930, followed by further enlargement to the down sidings in 1935. The sidings were mainly wagon load traffic, but latterly a staging post for coal trains from the Midlands coal mines to Didcot. I was interested in the next fact I got from Midland Railway was that intense workings prompted a proposal to electrify the route between Washwood Heath and Didcot via Banbury and Oxford, but was not carried out due to the logistics of transferring between diesel and electric power at both ends. The sidings were in use up until the 21st century, certainly the up sidings, and located on the up lines towards Derby. So let's go on to 1996. This is an old book I've got, which actually shows where the sidings were until the 21st century on the up line towards Derby. So you have on the Washwood Heath yard, plus the stone terminal and the Metro Camel carriage works and Alstom. Carrying on for another 10 years, and this is the quail map I had for the siding shown in 2005. In the 1970s, Washwood Heath was a staging post for automotive traffic, including MG cars from Abingdon and Oxford Cowley, and automotive traffic Rover and Jaguar. And they continued to late 2008. In fact, MG cars, when I started my career as a guard in 1975, I used to take MG cars from Abingdon and Oxford and take them to Washwood Heath. So after 50 years on the railways, come around full circle. In 2008, the depot was closed. And as an aside, 2017, HS2 received the role of stent, and we'll go on to that a bit later. After which, in 2020, Tarmac opened some new aggregates and asphalt facility on the old up sidings. So last glance at the old, this is the Metro Camel works, and you can just see in the top left, there's some construction works going on. So this is the very initial works for HS2. So this is the Metro Camel work. So there's a comparison between the heyday in 1935 and where we are basically in 2022. The bottom line is the section appendix diagram showing different tracks that are there now, which are very few and far between compared to what was there before. Okay, so that's a very potted history. I hope it was okay. So now we'll talk about basically how Washwood Heath Depot proposal started between 2014 and 2019. This is a map showing where the depot fits within the landscape. As you can see, the depot is located to the west of Bromford Tunnel, which is to the top right of the drawing next to the M6, and between the tunnel and Curzon Street viaducts. And the line heads towards the proposed HS2 Curzon Street station on the left-hand side, near to the old Curzon Street goods station. As I say, it was initially identified by HS2 as a preferred site in 2009 to maintain stabling trains. And there was a short list of sites. There was about 80 odd sites, long list of sites, about 80 sites. Then it was shortlisted to about 5 sites, 4 of which were in the Birmingham area, East Birmingham, 1 was in the Manchester area. And Washwood Heath was chosen as a ground hill site because it is an optimal land resource. And then after 2009 and 2012-13, there were some further reviews of the site for the depot, with some possibilities of siting it near Birmingham Airport and some other greenfield sites. but Washwood Heath site was decided to actually site the actual depot at Washwood Heath because it's near Curzon Street, near the local workforce, and a sufficient site size. Okay. So the Washwood Heath depot will be the primary maintenance and stabling facility for the HS2 train fleet that will also house the network control centre for HS2. Depot will serve as an operational and maintenance hub. Activities to be undertaken including light and heavy maintenance, servicing, testing, and interior and exterior cleaning of HS2 passenger trains, and to enable rolling stock to be stored when not in use. HS2 rolling stock depot will need to maintain and stable the trains, and there's one maintenance depot operating 24 hours a day, 7 days a week. It's going to maintain all these trains at the moment. Although other stabling facilities could be located elsewhere. In times of perturbation, it's possible to stable 54 trains on this site. But in times of perturbation, you can't always get the trains you have on this site. So there will be some stabling at Euston, Old Common probably now, and Birmingham and other sites. Okay, now the depot is going to be used for inspection, repair, internal, external cleaning, light and heavy maintenance, toilet tanking, emptying, rewatering, and the replenishment of consumables. And the flat site was located about 2 kilometres by ½ kilometre wide. And the West Midlands location is preferable to London as it will benefit in terms of availability of suitable sites and the cost and availability of skilled labour. Okay, so the depot will be, as I say, will be the primary maintenance and stabling facility. It will comprise a plain line track, S&C, to create stabling and servicing sidings with associated platforms and walkways that will provide depot staff with access for cleaning and servicing the rolling stock. It's 24 hours a day, 7 days a week, and it's a phase 1 depot for rolling stock inspection and repair. Now, phase 2 is being cancelled at the moment, but it's still going to be, the phase 1 is still going to be located at Washwood Heath. It's not sure at the moment from Network North where the further depots are going to be. There was one proposed at Crewe, and there was also proposed a bit further north, but that's in abeyance at the moment. Previous scheme in 2014, the hybrid build was put forward in 2014 with the layout based on the diagram shown on the screen. Now, the diagram shown on the screen, if you can see it, it's a bit faint, but there are 3 balancing ponds in blue, as you can see. There are also the top of the drawing is the proposed HS2 main line. The bottom block in the middle of the drawing is the proposed maintenance building, and around that are proposed sidings. So you can see the maintenance building is a single-ended building. To get from the main line into the maintenance building, you have to do 2 shunts. You have to come in, then out, then in again. And that was the hybrid scheme in 2014. In 2017, amendments were made to the track layout, and you can see now that the track layout has the maintenance shed on the right-hand side, the stabling yard in the middle of the picture with a connection between 2. So you don't have to do double shunts, triple shunts even to get into the maintenance shed. You can go straight into the stabling sidings and then into the maintenance shed. So for future reference on the talk, these are the main areas that we're going to be talking about. So from left to right, you have what's called the AVI and the CWM. So it's the automatic vehicle inspection and the carriage washing machine. You have a rail overbridge, rail overbridge, secondary access, heavy cleaning and paint shed, cleaners and drivers buildings, and stabling yard of 16 stabling tracks, test track, the NIC, which is the network control centre, and then you have a wheel lathe and maintenance shed. So those are the main, and gatehouse access building. So those are the main buildings. At the time in 2017, the land take had been determined. There's an option to take a certain amount of land take, and the green land take in the area is not Washwood Heath, but it's for development and a development area for future employment, future development land. This will be brought forward by a developer via a future planning application in the future. So that's been safeguarded. And as you can see from this bit of a better diagram, this shows a bit better the landscaping around the site. Note in the middle there's a block pointing to here, which is where the control centre is now to be based. As part of the route allocation and looking at the actual route, there was also a look at the flood zones, and luckily the depot area is flood zone 2, but to the north of the depot area there's some very severe flood zones, so it's less of an issue in terms of flood areas. So in context, the Washwood Heath depot is located 4 kilometres to the north east of Birmingham city centre, to the south of the Heartlands Parkway, which is you can see Heartlands Parkway on the map on the left. The M6 is to the north. The the proposed HS2 main line is the red line. You can see where the cleaners and drivers and the network integrated control centre and the maintenance buildings are. Those 3 main maintenance buildings. So that gives you an idea of the location within Birmingham. The area is entirely urban, but there are some land comprising light industrial and commercial infrastructure throughout Washwood Heath. One of the designs, you can see the buildings are in sort of red colours. That was to try and mimic the red brick areas that they replaced, really, because a lot of the buildings there were typical red brick industrial buildings. HS2 wanted to keep the architectural aspects of that. The site is bordered by the M6 and the River Thames. It's to the right, and then you also have the canal, Fazy Canal, that runs along. It's a brownfield site, about 32 hectares in the area. So train access will be from the east and west, and there will be 2 western access roads on which the carriage washing machine and the automated vehicle inspection are located, and 1 east access road. So some of the quantities, if you like, a bit difficult to read maybe, but it's 40,000. The maintenance building is 40,000 square metres. Cleaners and drivers is a 20th of that, 2,000 square metres. You've got an automatic rail vehicle inspection building. You've got 24 kilometres of track, 20 kilometres of OCS, 63 S&C units, a lot of S&C, lots of highways. It's a mini town basically, because it's highways, railways, and the interface between people, pedestrians. It's a mini town. You've got 80,000 metres squared of platforms. Let's take other examples. 100 metres squared of car parking. These are all approximately the time. But, okay, let's have a look at the track layout and the track form. The track normally is SEN 60 design. There are possibilities of making it SEN 56, but SEN 60 is the latest design requirements. Maximum depot siding speed is 25 kilometres an hour. There are some slow speed areas as well. The departure and arrival track speed is 80 kilometres an hour, and the test track is the same. So the single diagram essentially is you have main line at the top, and from the west you have the west link. This is a single turnout access to the west access tracks, and 2 west access tracks, and then you go into the fan for the stabling sidings. Then after the stabling sidings, you get another fan to go into a double track. Then you go into a 3rd fan, which goes into the maintenance building. From the east, access from the east is via the east access line and the east access reception and the east access head shunt. Then you get into the head shunt, and then you reverse back into the sidings and then the maintenance shed. That's the only shunting move you do. Coming from the west, you can go directly in. So what are the S&C types? The S&C are UIC standard S&C types from UIC 711. and typical angles are shown. This is the a table showing all the turnouts available on HS2. So the scissors 60, 30, 1 in 14, and 1 in 19.16. That's from the main line. All the other ones are used in the sidings. So basically, they are the ones that are in use in the sidings are mainly where it's 80 kilometres now, main line, and diverging is to 40 kilometres now. Let's have a look through the track layout in a bit more detail. Starting at the west end, there's a single turnout connection from the main line to the depot access tracks. So it's a single line, then it goes into two lines, the west access 1 and the west access 2, as we're heading east. Continuing east, the tracks then run alongside the head shunt. The head shunt, I haven't got vertical lines on here, but the head shunt, which shows east access head shunt, if you can see it on the screen. To the left of the head shunt is a buffer stop, and the line that goes across in grey is also a canal. So there are some issues because the gradients of the west access lines is steeper, is too steep for a head shunt, where the head shunt may require trains to stand. So the east access head shunt has a different gradient to the west access lines, which means that there could be some issues with the buffer stop and the clearances between the east access section and the west access. We'll show later in some cross sections. As we go further east, we head towards the AVI and the CWM. So the AVI CWM, you can just see on the left, right in the left-hand corner, it says depot boundary. The depot boundary is basically where the depot operations start and the conditions start. So all the dotted areas show slab track, and that's where the slab track ends basically, and there are different track forms to the east of that. But that's a nominal boundary for the depot. So you can see the idea is that you're able to wash two trains at the same time, two 400-metre trains at the same time. So there's a scissors crossover leads to diving underneath the bridge and the SES overbridge, which is the existing railway. Bridge has just been replaced last year, I believe. So it starts off with the siding fan, the track running towards these stabling sidings. 16 stabling sidings, they can hold two 200-metre trains each with a 40-metre gap between them. So there's a long distance free stabling. To the north, you can see the access to the test track. That's you've got east access, which is from the main line. Top two tracks are HS2 main line. Next track down is the access from the main line. The next track down is the test track. And then we head towards the eastern fan. Eastern fan, to the north of the eastern fan is a building, which is the infrastructure maintenance zone. There are some infrastructure maintenance tracks going to be provided here as well for minor maintenance. And there's a scissors crossover, which is on the right-hand side in red. That's a golden asset, I would say, because if that goes down, then one of the criteria that HS2 have is to not have any golden assets. But unfortunately, due to space limitations, they've had two, because you have a single track coming from the main line into the sidings, and you've got a scissors crossover on two tracks. If you remember, in the 2017 scheme, there were 4 tracks in this area, but now there are only 2. So that could be an issue in the future. Then we get into the next fan, which leads to the maintenance building. And which includes a wheel lathe building to the top of the maintenance building to the north. And then you can see at the start of the maintenance building, which consists of 5 inspection roads, equipment drop road, bogey transfer, and a couple of heavy lifts. And last drawing for the maintenance depot shows the end of the maintenance depot, and the eastern gatehouse is on the right-hand side, and there are some office buildings to the right as well before the car parking. Let's have a quick look at the track form. I'll go through this a bit quicker. Basically, there are 5 types of track form. You have embedded tracks, ballasted track, pitted tracks, slab tracks, 4 types. And there's the slab track is what's shown in pinky colour, because the main HS2 is all slab track. So the S&C is based on is located on slab track through here. As we go further east, you can see that slab track continues. The head shunt also is on track, and then you carry on to, you've got ballasted track now as you go. Sorry, slab track still with ballasted track when you get to the after the transition zones. The crosses in black are the 10-metre transition zones between the slab track and ballasted track. So the rest of the sidings and the turnouts are all ballasted. And it's ballasted track throughout the stabling sidings to the other end, and then you get some tracks in pits and through the actual maintenance depot. So those are the 5 different types of track form. A bit about rolling stock and what's going to be stable at the depot. The rolling stock contract has recently been signed between Hitachi and Alstom to build the trains and to create 2,500 jobs in the UK. Hitachi Alstom High Speed Train joint venture has signed contracts with High Speed 2 to design, build and maintain the next generation of very high speed trains for HS2. It's due to start rolling off the production line in 2027 at the moment. And they're 8 carriage trains measuring 200 metres in length, be manufactured across 3 factories. And Hitachi's County Durham plant will do the vehicle body assembly and initial fit out before transferring further fit outs and testing work to Alstom's Derby Works, which has a big history of railway works. Excuse me. So the trains, 225 miles an hour capability. Well, they won't be doing that in the depot. 400 metres long, as I said, and they've got 1,100 seats. Rolling stock gauge, the minimum curvature gauge it's called the USG4 depots and sidings gauge. So this is the gauge used just for the sidings, and the minimum curvature. A 400-metre train in any payload condition shall be able to traverse 150-metre curve. The S&C, sharpest S&C we have that's been designed is 190 metres. That's fine.
Vehicles that switch where though, because I imagine these vehicles go quite high yaw stilts, stable speed.
Yeah, they are. There will be. And one of the big issues is the reverse curves through some of the S&Cs and for S&C.
So what's your typical switch radius?
Switch radius is 190. So that's, yeah, but that's UIC standard. UIC standard has 1 in 9 turnouts, for example. We wouldn't do that. We do 1 in 9.5 or 1 in 13 or something like that. 1 in 10 3/4.
But that's what you are doing. You don't have to work the standard, do you? You can better the standard.
We can do, but the design has been done based on the limitations of the space, really. So I was going to talk a bit about the signalling. I've not been advised about the latest details of the signalling, but the HS2 limited mainline train control is going to be the RTMS, which is basically ETCS and GSMR, with automatic train operation in part of the sidings. And the depot will include the provision of telecommunications support infrastructure, including train control, depot signalling system, separate control centre, which is housed in the maintenance building, not at the NICC, because there can be an alternative control centre, and that will manage all depot train movements, extending to an agreed transition point, the mainline train control system. They're going to be specially equipped track within the depot to test rolling stock systems as well as part of the test track. Okay, let's talk a bit about electrification. The depot is going to include a 25 kV AC OCS design, and most of the track layout will be electrified and capable of electrical isolation from the mainline system. It will include infrastructure for traction power system within the depot and the HV/LV non-traction power distribution system that serves the depot, plant equipment and buildings. Excuse me. The OCS height range will be different. The HS2 normal pantograph height is 5.12 meters above rail level, but at Washwood Heath it may be lower. It may be a slightly different type of OCS system. There's also issues with clearances underneath the bridges that have been redesigned. These are some of the cross sections, as I said earlier. So this is the cross section of the Saltley Viaduct, which shows on the shows the main line on 2 tracks on the right hand side. 5 metre track centre, 4 metre track centres here in this situation, plus the 2 that'll be the 2 access lines that Saltley Viaducts. The bottom diagram looks a bit odd because it shows 2 bridges without support in the middle, but it just happens to be how the CAD drawing is showing. That's actually where the railway goes over the Warwick Junction Canal. A couple of others show, I talked about the difference in gradient requirements for the head shunt. That's the track in the middle, which is lower than the other tracks. So there has to be some protection with retaining walls and ensuring there are positions of safety. Again, further along the route, it shows the locations of the OLE masts and some of the areas for the AVI and CWM. This is the SAS overbridge, which was recently rebuilt. It was middle of last year, and Ashton Church overbridge as well. So those are where there are some quite tight clearances for the railway. Let's go on to the buildings and architecture. Now this basically is a nice CGI diagram, which is from the Schedule 17 drawings that HS2 produced for the maintenance building. If you can see, the right-hand side shows where HS2 will be coming out of the tunnel. So on the right-hand side, you can see a covered lattice of tunnel, the retaining wall. And then next, to the left of that is the test track, and then the maintenance building is in the main building. You can see in the distance of the stapling sidings. So the largest building in the rolling stock is the rolling stock maintenance building, which contains, as I said, tracks for inspection and maintenance, and bogie equipment drop and heavy lifting. Inside this maintenance building, each track will be fitted with OCS, which is likely to be a rigid beam design, which can also be movable sideways, and we'll have a pantograph test facility. The maintenance building will also contain offices for whatever the TOC's going to be, and a number of workshops and areas for materials and tool storage, all of which are provided by the depot and the contractor. It's the largest building proposed at Washwood Heath Depot. And will also house equipment such as gantry cranes, access galleries, maintenance pits, heavy lifting equipment drop facilities, and equipment for activities such as windscreen changing. It's about 320 metres long and 100 metres wide, and the wheel lathe and the painting shed will adjoin the mating buildings to the north and south respectively. So to the north, that little greenish block to the top north of the mating building is the wheel lathe, and the train on the left is sitting on the painting shed.
So they won't be able to fit a complete train in the building then. If it's 400 metres and the building's only 320 metres, there's a 80 metre short.
That's true. Not on the same. You can fit a 200 metre train. Okay, these are some nice CGIs also of the side of the building with happy people and lots of nice sunny weather.
It's the job. Yes, it should be raining.
Should be raining, shouldn't it? Yes. So a typical long section through the building, which shows elevations. So it's not a very tall building, but it's a pink colour where it should really be a reddish colour. It's come out as pink to try and mimic the different types of construction that was there before. And this is just the end of the building showing the relative proportions. In plan area, you can see at top left the wheel lathe building, and as Martin said, you can see the train in 1, 2, 3, 6, 7, 8 trains in sidings at the moment. The right-hand side are the offices and stores. And the light maintenance buildings are the bottom 5 tracks with heavy maintenance top 2. This is a cross section showing them. So on the right hand side, you have your inspection maintenance sidings. The left have heavy lifts and pits to actually take out equipment from underneath the train, and also the proper lifting jacks for the train. Looks from the other side. That's from the other side as well. Okay, let's go back to that one. This shows it from the fan. So on the left-hand side, we have the wheel lathe, the bottom picture, and the sheds, the building openings on the right-hand side. The roof lighting has been quite a design. The roof lighting is made of photovoltaic solar panels. And that's part of the carbon net zero requirements. And to actually have those details, and they're quite tall. You see a man standing there, it's quite high actually. And this is a typical cross section through an axisymmetric section through the side of the building, showing the canopy structure and the external doors and relative locations of the OCS and the train. Maintenance building, this is the roof of the maintenance building, and these are all the photovoltaic cells. So there's lots and lots of them. There were more before. There were the cells were at a different angle before, so they were slightly different sizes. But yeah, it's quite a lot of cells. So as I said, sustainability in the environment is a key requirement for HS2. So there are a lot of things that HS2 are doing to show sustainability for both the maintenance depot and the NIC. So providing natural daylight, the solar panels, the photovoltaic cells, green spaces on top, natural ventilation, energy efficient equipment, sustainable transport, electrical charging, sustainable drainage, biodiversity. So it's the whole gamut of sustainability requirements. Okay, let's talk about the NIC building. The NIC is the Network Integrated Control Centre building, and it's proposed on the central area of the depot site. It will be the heart of HS2, essentially, heart of the railway control centre, not just for the depot, but for the whole of HS2, and it's been constructed separately. It's a highly sensitive building requiring security fencing internally within the depot. And the building will be approximately about 8,000 metres squared in size, with car parking for staff and visitors to the eastern side. In addition to the building infrastructure, there'll be the foundations, substructure, superstructure, cladding, lighting, acoustics, heating, ventilation, drainage connections, power connections, and building services, including HVAC, Wi-Fi, security systems, video surveillance systems, access control building IT, and fire suppression systems. So there's an awful lot of integration of different systems within the NIC. Any of which go wrong, then you have severe problems. Protection of the OCR, the operational control room, in the event of fire and flooding or terrorist attack is of paramount importance. And the building is going to be located and orientated and designed to prevent and minimise the impact of terrorist attack, fire or flooding, or freak weather events. So that the HS2 network is able to continue operations, because this is the heart of the HS2 network. So the next very similar building, standalone building within the depot, designed to accommodate the operational management functions. So it's a similar design, architectural design to the maintenance building, similar colours. As well as that, the next important building is the cleaners and drivers building. The cleaners and drivers building include offices and welfare facilities, stores and training facilities and train simulators. I should also say that the cleaners and drivers and the maintenance building and the NIC also contain faith rooms. They have a gym in them. They try to promote well-being for their staff. I'm not sure how many signallers will go to the gym, but the faith room will probably use. So the cleaners and drivers building will be on the west side of the depot, clearly, and will house general offices, meeting rooms, breakout areas, and training rooms and classrooms. There's an underpass from this building. Let's go to. This is a plan of the building. So first aid room, entrance lobby, you've got canteens and briefing. Faith room is not shown on here, but it was on here before. So and there was a gym on here before, so that's changed. All right, faith and quiet area. It's a very small faith and quiet area, I must admit. It's the little block on the left hand side. Well, yeah, I'm considering the religious, the number of Muslims and other faiths in that area, I would expect it to be a lot bigger, to be honest. There's a technical library as well, and drivers fixed.
Minaret.
And as I say, the actual building is a similar style, similar design, similar to the other buildings in terms of the facade and the axisymmetric view. Is very similar, very similar architectural design. This is a typical landscape drawing. Building on the right, showing the access and the landscape and the trees that are proposed. I just want to go through some of the other buildings. There's an infrastructure maintenance building. If you remember, I said it was to the north of the eastern fan. There's an infrastructure maintenance area. There's a building for that, which will house the stores, any requirements for cleaning. There is also an underpass. Now, this underpass to the right-hand side of the bottom drawing is the cleaners and drivers building. So the cleaners and drivers building at basement level will have access underneath the tracks along this underpass. And that underpass is halfway between the trains. There's no requirement to provide walking access at rail level. There are two emergency access ways, but only to be used in emergency. This underpass is for general use by cleaners and drivers to get access to and from the stadium trains, stadium platforms. And you can see that it's you can see the cleaners and drivers building in the bottom middle, right at the bottom middle of the drawing, and the black blocks that you can see to the right of that is a line showing in black where the actual underpass is. It's not quite halfway, it's just to the right of the inside. Okay, there'll be other specially equipped track within the depot to test the rolling stock systems. That specification has not been agreed yet, but that's on the test track, which is to the north of the stabling sidings. The test track are proposed in the northeast of the depot site within a fenced enclosure, and a dedicated test track buildings will be provided to the far east with a 1 kilometre length test track. The test track maximum speed, last time I heard it when I was doing the design, was 80 kilometres an hour, but that may have been reduced because the train's not going to be doing 80 kilometres an hour in a kilometre. It may start off and then speed up to 80 kilometres an hour, but it has to brake pretty quickly. But it's for tests. It's not doing major tests for the rolling stock. Just doing some minor testing. The AVI facilities will be provided by the TOC, and the contractor is going to design a suitable covered building in accordance with the constraints in the works specification. Okay, there's also at the east end of the facility and the site-wide facilities, the gatehouse. Again, a small security structure integrated with the proposed Wolseley Road highway and vehicle refusal work. So at the east of the depot is the main road access to the depot. and its gatehouse is at that access. Sits within the wider depot fence and secure line. And again, is a typical very similar architectural design and colouring to the other buildings. See corrugated cladding, aluminium frame glaze system, and glazed spandrels with demountable facades. I'm not sure what colour the zinc will turn into in 20 years' time. I don't know, but one of the ancillary buildings, or the area of the ancillary buildings, are the carriage washing machine and the automatic vehicle inspection area. These are single-storey buildings. In addition, there'll be speed control systems in increments of 1 kilometre up to a maximum 25 kilometres an hour on these tracks, because they'll be controlled through the washing machines. Because, as I said before, you can get 2 things washing at the same time. So this is again a typical area of stabling facility in long section, showing 2 trains, stabling points. Detail. And this is a cross section showing the stabling with washing area in the middle. The walkway level is the same level throughout the whole depot, so 93 metre walkway.
Just go back one.
Yeah.
So the tracks curve before they exit the building.
Some of them do. This is the stabling area. The
Right.
bottom track.
This is within the building.
Yeah, it's not within the
Oh,
building. It's in stabling.
Yes.
So the maintenance building is all curved. It is all straight, but this is curved here. So that's typical stabling. We also have some under frame cleaning areas, which is just to the south of the main stabling area. And then this is what I said before, the infrastructure maintenance building area is shown just to the north of the easternmost fan. So there's a couple of tracks to the north, and right at the far north is the test track. And that's fenced off, completely fenced off from the rest of the sidings, because they'd be going far. The trains could be going faster along there than the main sidings. So that's fenced off. There's also automatic train operation through that area.
Did you say that was 1 kilometre long?
Yeah.
And you said your trains are 400 metres long.
Yeah. But they're 200 metres, but they could be stapled in 400. So
Right.
they'll be tested at 200 metres.
Okay, I think it's slightly more.
It's I know.
That's literally everything of that accelerator and stuff.
Exactly, yeah. So there was a move to, the initial criteria was 80 kilometres an hour. And then the move when we do the design to say, well, why don't we just test it at 25 kilometres an hour or 50 kilometres? So you can at least get up to that speed and then stop. But with 80 kilometres an hour, you have to do special designs to the buffer stops at the other end, for example.
Yeah.
So, just make it slower. You can still do your tests that you need to do. The other tests for higher speed will be done on the main line anyway, the main line testing commission. Okay, let's have a few more slides about landscaping. I've showed this before. This is the main landscape area, the sidings. So you can see in the green. You can see in the green below all the tracks and maintenance. It's the main landscape areas. There's not much to the north of that because it's near the existing tracks and the existing sidings. So you can see this is this is not exactly the latest drawing because the nick is not quite in the right place, but it's not the right shape. But the area has been moved to the west as well, but the landscaping has not changed very much. As I said before, the balancing ponds, which are in the hatched areas below the red line, which is in the safeguard area, those balancing ponds are being designed under a separate contract. And they will be used to, as it said, to use to balance the areas which are outside the depot. The blue area to the middle of the layout at the bottom is also a pond. The green bit to the really blue bit to the right of the nick is also an attenuation basin, which will be dry most of the time. If it does get a lot of heavy rainfall, then that can be drained into the balancing ponds. But the development of this area is yet to go ahead. You can see the existing housing in the bottom grey. Those are the safeguarding lines. There's development proposals for this area. Those development proposals include industrial development, but also housing. So what's been happening with landscaping and with the carbon net zero is HS2 have specific plans for carbon zero. They want net zero by 2025 for HS2 limited corporate activities, a 50% reduction in carbon emissions by 2030. This diagram came out last year, so this year may have changed that to 2035. There's 100% carbon electricity to power trains. Well, that's going to be the case. That'll be 100%, and the residual carbon emissions offset from 2035 is 100% as well. So it's proposed to have construction and operation net zero by 2035. That's the proposal. And as we said earlier, this was the old landscaping diagram with the balancing ponds. The attenuation basin will be for management of water within the depot, allowing attenuation of surface runoff associated with the depot itself. The on-site basin has been geometrically designed to integrate this significant landscape feature into the wider site landscape. 2 attenuation basins are provided in the area south of the depot boundary, and they're going to be subject to separate Schedule 17 requests for approval. And I think we've seen this drawing before, but this just shows that overall area that's going to be used for development. I think I have one more slide left. Please, I'm not allowed to go in to talk about construction or programs. HS2 have not allowed me to do that because they're not sure about the construction periods and continuation construction. All I can show you is a map showing where we are or where they are. And basically, the site is a complete construction site. But on the bottom middle of the slide is where the Nick is going to be based. And the Nick, that does say Nick's barbershop. It's nothing to do with the Nick. It's only in there. The Nick has now been, the excavation has been done and the earthworks have been built up to the 93 metre above ordnance datum level they're supposed to be. So they've almost completed their earthworks. There's a considerable amount of work to be done for the railway is up in use. The original proposal was to have it in use by 2033. I don't know when that's going to be achievable or not, given Network North, given what's going to happen with the rest of HS2. Okay. That was a very quick crawl through. Any questions?
Okay, Dick, go on.
Yes, you've mentioned 2 or 3 times something called OCS.
Yes.
The only familiarity I have with that term is on the company's service.
Okay. Okay, it's OLE. We'll call it OLE. HS2 call it OCS, overhead catenary system. That's a European term for
OCS, but you get a penny off a cup of tea.
That's it.
Yes. You get a cup of tea.
Yeah, no, it's the electrification system. It's a international term, whereas I used to call it OHLE when I was a guard, when I was in PWA, not OLE. But the electrification EMP people call it OLE, but it's OCS if you're HS2.
Okay, I'll go to the home. There's chap Peter Halliwell. You want to ask your question?
Hi, good afternoon. Good evening, Matthew. That was a fascinating talk. Thank you for that. Has your role been in leading the design of this depot?
No, my role is assuring the design that was carried out by others.
So my question, I'm really interested in how you approach this. The purpose of the depot is for stabling and maintaining the trains,
Yeah.
and the depot's been designed and is being built before the trains have been fully specified and designed and built. What flexibility and contingency is there in the way that it's been designed to allow for requirements that will come from when the trains have been designed and specified? The trains have to fit the depot, or does the depot have to fit the trains?
Well, it's a bit of both. The depot has been designed based on a given kinematic envelope provided by HS2, within which the rolling stock has to sit. And that's basically it. And the rolling stock design has been based on, I think I showed the USG4 overall clearance gauge within that gauge. So now because the designs have been done for the depot, the construction is not done yet. Clearly, the rolling stock has only just been procured. So as long as the rolling stock is within that kinematic envelope, then we should be fine. But I'll take your point. Which comes first, isn't it? No, you want to know.
So it doesn't affect things like locations of pantographs or underslung power or any of that. That can all be part of the internal fit out.
It has to be the internal fit out, but it also has to be part of the integrated design. So, and we all know about railways because all the different disciplines, it's an iterative process, isn't it?
Yeah.
We all know P-way comes first because it's the most important discipline. Actually, operations is probably the most important because without you don't know what to design, but without alignment you can't do anything. It's right. Now the rolling stock has been procured. The design is now going ahead within quite a tight criteria rolling stock specification.
And it's definitely constrained to it. Yeah, sorry, it's definitely constrained to a unit length of 200 meters then.
Which, well, it's nominal 200 meters because it's 200 meters plus or plus 10%, I think, is the phrase. Is the number. So it ends up being plus 5 meters. So it ends up being 207 meters. 200 is 200 plus 2 plus 5 allowance. So it's within that. But in terms of kinematic envelope, then it's stricter on the actual body size.
Does it include shore supplies as well?
Yes, it does.
Okay, brilliant. Thank you very much indeed.
Phil?
You put my interest when you mentioned the slab track systems, of course. So what drove the decision to have some of the depot track in slab track and to put the transitions there? It's I know most of the mainline track is going to be slab tracks. So obviously you're coming in on slab, but
yeah. So that was one of the reason. There was a big argument about whether it all gets put in slab track or it all gets put in ballasted track, and also an argument of where the boundary would be and who's responsible for the maintenance up to that boundary, because the boundary reflects the maintenance boundary and reflects the speed boundary as well. So it was decided very early on that slab track would be the boundary and it will be ballasted track. As I said, there are lots of other. There's embedded track and there's pitted track and there's ballasted track as well. You could argue that some of the turnouts are quite sharp turnouts. They're quite. They could do with being more rigidly fastened, if you like. As you can see, there's a lot of movements. It's going to be a lot of requirements for maintenance of that ballast, and it ends up being costing at the end of the day. But yeah, but it was decided that from an early stage that because the main line was going to be slab track, that the initial turnout from the main line would be slab. Then the two main turnouts into the access lines will be slab. And then let's choose a point where we start the depot, make that slab, and then it's all ballasted track after that.
So the S&C, say on the stabling siding, the S&C and the plane line are all on ballasted track. Okay. So there is a limited number of transition slabs and so on then.
Yeah, the transition slab. Yeah. So where you split, there'll be a transition slab. So that'd probably be about 2 or 3. Well, no, 5. I think there were.
Yeah. It's not on every siding.
No.
Thank you. Just a question about the drainage, obviously. See, there was a 24 kilometre track at the start.
Yeah.
In the Biddeford, and
Yeah.
24 kilometres of track drainage. That
Yeah.
seems quite excessive. Is there a reason? Do you know?
That was the quantity at the time. And it was just assessed that you need drainage along each of the sides because it's imbalanced. It all ties into, there's a big main drain down the middle, which goes into the outflow drainage onto the Thames, River Thames, and that's where the drainage runs. That's what we designed at the time.
And the follow-on question is always one I'd love to ask, which is ongoing maintenance and inspections. So there's probably loads of contracts for train care and track. Is there actually anything for landscaping, tree pruning, grass, things?
There is. There'll be a contract. I don't know if at the moment there is, but there'll be a contract for provision of landscaping. And I don't know about a contract for maintenance. And you're right. If there's lots of trees been put in, make sure it's maintained. Obviously, that's because it doesn't get into the drainage. Once it passed.
That's good. It was interesting early on, especially, well, it's all been interesting, but early on to see the macro changes in the layout of the proposals. I mean, how does that happen? I mean, does one person decide, well, let's try this, and then it gets kicked around? It worked up to such an extent before a major change in the distribution of the elements, and even like the nick. Moving around slightly. I mean, how does that get decided?
Well, the thing you have to start off with an operational plan of a signal line diagram of what you want.
Yeah.
And then you know how long the train's going to be, and then that tells you. And then you've got an area you have, then that tells you how you can fit it in. And then you've got to do some sort of simulation of how you run your trains.
Right.
And sometimes that changes the signal line diagram you produce. So you produce another diagram, you produce another drawing to see if it works, and it's all iterative. And then you've got to look. Then if you look at the things with S&C design, is you can't really do it concept design because you need to know the exact lengths of S&C. They're almost a detailed design because the detailed design for S&C nowadays is just 3 or 4 points on a diagram and you just plonk it onto CAD. We also need to know those. Because you can't just say, well, I'll just fit this here, I'll just fit this here. If you do that, you do your operational analysis, you find, okay, we can't get these trains, 17, 18 trains an hour or whatever they're going to run, trains into and out of the depot, can't get these to run. Let's either add another siding or do some changes to the track layout, which requires another drawing. That's our key way to go along, isn't it? Anyway.
I mean, how many people is a team of 3 people who just sort of know what they're doing? Or I don't mean that flippantly, but I think it's.
Well, it's head of on my dining room table with a few rugby. Right. No, it's all done in CAD.
But is it really a tiny number of people who really knock the design together between them in general, or is there quite a lot of committees or?
There's not necessarily committees, but there would be a team of people, of operational people to determine about the concept. What is concept operationally? What do you want to do? And how much land do you need? And that's how the land was chosen. It's taken since 2009 to 2019 to actually find a site that's suitable and big enough. And then you iterate through those and you do some value engineering, because one of the value engineering exercises was reducing the amount of tracks between the stapling sidings and the maintenance shed to leave you with a golden asset. Because there were 4 tracks there before, now there's 2. Save money, give more room for landscaping, room for the nick. But you have the risk of this piece of S&C could fail, and it had a whole lot of failures. So you end up buying a second one and leaving it in the stores, so you can replace it quickly, that sort of thing. But it is, I mean, there are lots of people in lots of committees that look at the risks and look at the what ifs we do this, what if we do that, and it's every time I guess the drawing produced, you look at the drawing, and you end up looking at the pros and cons and the costs and the benefits, and environmental issues and all the different issues, and then you show it to the public, and the public say, do that. Not can't do that because that's this, or you don't have up-to-date mapping. The mapping you've done at the concept stage is not digital OS mapping, and you know the latest mapping. and you haven't been on site and you haven't found out that there's a building development going on that you didn't know was there. So there's all these things happen at the time until you try and get some sort of alignment design that's honed in, taking into account that you've also got the mainline HS2 alignment that's moving as well around the snake grid. So it's got to try and fix that, because if you move your HS2 alignment, then everything gets moved.
Right.
Tony, you go.
You've mentioned these high-risk golden assets, golden assets.
Yeah.
Does that include the turnouts on the main HS2 main line?
Yeah.
I'm surprised that there's only one entry and one exit, because I thought
That's one
that
thing
would be
I-
very high risk.
A couple of years ago when I looked at the design, I didn't do the design. Assume the design, that was one comment I made, why you only got one turnout. Because you've got turnout filled by crossover, so
Yeah.
you don't get one train in, one train out.
First question, what is the turnout speed and what's the main line speed?
The mainline speed through there, I think is not 225 miles an hour, I think it's 2K. I think it's slowing down when it goes into Curzon Street, but I don't know the exact speed. But the turnout speed is 80 kilometres an hour.
And does that have much impact on capacity on?
It will have, because it's a lot different to the mainline speed. And you would have thought that if there was a second track in there, you should get parallel movements. You could allow parallel. Because you've got two tracks, you've got the access track 1, access track 2. Because you split once, you go in once, and then you split again. So one just have another turnout.
And then the second part, if something does happen, one of those turnouts, particularly one at the west end, so you're only operating with the east end, what impact does that have on the capacity
Well,
of the depot?
that completely messed it up. Because most, I mean, the trains likely going to be going into Curzon Street, and most of the trains are going to be coming out of Curzon Street, going through that single turnout. They're not going to necessarily be coming from the east. They go to west, they go in without going into Curzon Street.
Yeah.
So it's unlikely they'll use that eastern access as much as Curzon Street, clearly. So again, you would think if more trains are going to Curzon Street and come back out of Curzon Street, why don't you make it a proper double junction?
Yeah.
With no limiting move.
That's just
I can't answer.
HS2 has been chopped up for the common. Presumably there'll be no servicing of trains other than light cleaning carried out deep underground at Holloway Common. So is it the plans now that the trains return all the way to Birmingham at night for exam and maintenance and then back down in the morning?
I knew this question would come up, and I couldn't get the answer to that, but I don't know the answer to that because I don't know what Network North is in for the rest of HS2. I know the project I'm working on at the moment, Northern Powerhouse Rail, including network HS2 connections with Northern Powerhouse Rail. So I think it's another side of Northern Network North that are looking at what happens with what was HS2, and it could still be depots further north as well.
It'd be an interesting day when the train arrives at Holloway Common and needs to go back on the wheel skate because it's an awful long way to go. Somebody pick up HS2.
Yeah. I mean, originally Washwood, one of the reasons for Washwood Heath is because it was central between phase 1 and phase 2. So take phase 2 out, it's not central as it is at one end.
Yeah.
But it's still central to high speed rail.
Well, he was trying to get a question.
It reminded me of something of 1975 when you joined us and you had been a guard.
Yes.
And your stepfather was a panel signalman.
Yeah.
So you had intimate knowledge of the railway. And I'm wondering whether you were the only bloke in that team who knew anything about how to run a railway. But the serious question is, would it have been done quicker and cheaper by BR?
I can tell you. Of course. No, when was HS2? Was HS2 previously put forward as a high speed rail back in the 70s?
Yeah, it was.
HS1 certainly was, but it was HS2. So there have been all sorts of schemes. Maggie Thatcher knocked out HS1, which is Uchi, but HS2. But there is much more governance nowadays on schemes by all sorts of committees and all sorts of assurance managers, like as I used to be, to make sure that the risks are reduced and the benefits, you gain most of the benefits you say you're going to gain. But you still get detractors from people who don't want the railway at all. But you also get people, there are a lot of people in Birmingham City Council who did not like the Washwood Heath site because it took away an area which they were proposing to have for industrial buildings for 1,000 workers, whereas the rolling stock site is for about 750 workers. So you're taking away the opportunities for a few thousand and just giving it to 750. That was one of the reasons that Birmingham City Council, some people in the council didn't like the site. They preferred to go somewhere else. So you always go back.
But you don't have all the environmental.
No.
Yeah, back then, you know, you didn't have all the considerations of the ponds and the trees and everything.
Yeah.
They've been concreted over and that would be the end of it.
There's been a lot of movement by HS2 to make it architecturally nice and environmentally zero carbon. So saying if you can ever get zero carbon, environmentally sustainable and for local workforce in a deprived area. Really.
Well, you were trying to.
Yeah, a technical question about the S&C. You mentioned UIC types. So is this something that's not following the Network Rail REPWs and Network Rail standard designs? This is
Good. Well, it's HS2. This is not.
indeed, yeah. But obviously, the UK manufacturing facilities are mostly set up to do REPW based S&C.
That's also a question I asked before.
So
No one talks about it.
are you sourcing from the UK suppliers, or
There will be sourcing. I can't talk about it because they're going through tenders at the moment, which is one of the reasons I had to get HS2 permission to do this to us. But I agree with you, HS1 are the same. HS1 have UIC turnouts. And I do get the impression that we've got turnouts that are fast, not as fast as UIC 711 because they go up to 230 kilometers an hour. But we do have some fast turnouts. Why couldn't we just use the ones we have? Instead of having yet another different design standard. Yeah, but 1 in 9s, we don't use 1 in 9s anymore, do we?
So 1 in 7.
It's on 7.5 as well.
Where's
There's a track points on there.
Oh, okay.
And 1 in 14 is not an actual number that we like, is it? Don't do that even with NR60, don't have 1 in 14. So you think there'd be some sort of what's the word? Consistency between the supply for a country. That's all. I think it's that all S&C. So we went to RT60 with NR60, so they're all an REPW.
no, you need a whole new suite of drawings.
Yeah.
Okay, have we got any more questions? Anyone?
Can I just make one comment, right? And
Yes.
Going back in history a little bit with it. Having worked sort of in the Derby, Nottingham and Leicester areas, we were quite used to marshalling yards in the Birmingham area. Washwood Heath was one that was always considered to be okay for all your wagon load stuff and so on going in. Wasn't really a problem. You could always find them. You knew the forwarding train and so on. What you always had that it was Washwood Heath and not the 6-letter word of Bescott. Like coal. And anything that went in there, lucky if you ever found it again. So hopefully Washwood Heath is going to have a bright future.
Yes. Yeah.
We got anything further from the homebound people? Okay.
Thank you.
Well, that just leaves me to say thank you to Matthew and ask for Phil to do the vote of thanks.
No problem. So you told us a fascinating story there. It brings to mind a story of mine. So when I was young, one of the things that's always stood with me is, to an outsider, the railway is blissfully simple. It is just train turns up, you get on it, it's got a traffic light on the end of the platform, you go through a door, there's nothing there. And then, of course, they get into the rail industry, it's like, it's a bit more complicated. And then you learn more, and it grows. And the big thing that comes is when you grow into the rail industry, the complexity that is there is fascinating. And the big thing that comes out of that, as you get into that and learn a lot more about it and go into the kind of roles that you and I are in, both I'm DPE, and presumably it's not called a DPE in Yeah, yeah, so yeah. But that kind of role, again, the amount of complexity, the amount of systems engineering that you're doing. And I'm sure the last time we did a vote of thanks, the systems engineering part is one thing that shines through. And even now, to some people in my own office who are very in their own disciplines and in their own bit, and I'm a track engineer and I do my bit here, and they don't really see the bigger picture. And well, actually, you can't change that because that is, I'm in a big argument at the moment about signalling. We're literally moving a signal 90 meters. It's like, oh, but that changes the overlap, but that changes the scheme pad, but that changes my power supply. Where's this? And the number of questions that come out of that is incredible. So when you start doing something like a depot, there seems to be often I've hit a perception in the rail industry that a depot is just some sidings over there, you just park trains on it. It's just a thing over there, and it's all simple. And then you start with a brownfield site, and you say, well, it's got this many sidings, and we've got this much S&C, and it's the heart of the railway. The S&C type. I didn't write down how many sets of S&C you had, but it's a lot. The number of things that you went through, the history of the site, understanding even what you're digging up before you've ever put something in, because you'll hit all kinds of buried obstructions, you'll find all kinds of odd history. And then you start trying to put a railway system on top of that, and you just try and work out how you can safely get your cleaners to the trains. You work out how you can safely look after your staff. You can work out how you get all electrical supplies, you can have all your isolation limits, how you access them, how you run your operations. It's a fascinating story, and building that from scratch is a brilliant thing to say. And you've taken us through a really good, history, a really good description of all the integration. And I love the complexity. That's what I love about my own job as being a DPE. It's bloody annoying sometimes. It's bloody hard work sometimes. But actually, when you look at what you're achieving, the cross sections, the ballast, the ballasted track, the slab track, the pits, the embedded, all the different things, and each of those has its own level of complexity and its own level of systems. You try and bring in the safety, you bring in the sustainability, you bring in the carbon, you bring in the PV panels. I'm getting the PV panels at the moment, they're not easy. I'm sure you share many of the questions I am fighting through at the moment on PV panels. They're not just a thing you put on your roof and leave there at all. And it's just fascinating. So I don't know if that in any way captures your talk there, but everything about this whole talk and indeed many talks it's complex, it's a system, it is a fascinating set of interwoven disciplines and considerations and stakeholders and people who support you and people who hate you, and a myriad of systems and things to work through. And well done for doing it. Thank you.
It's like designing a town.
Yes, it really is.
Not just a railway.
Oh yeah, very much. Yeah, indeed. So, thank you very much.
Thank you.
You want to join us in the normal way? Thank you.
I'd just add my thanks to Matthew for that. There's 101 slides there, and putting 101 slides together is not an easy task. That in itself is a complex list to prepare, and especially have somebody watching over your shoulder, making sure you're not saying the wrong thing. So thank you for the hard work you put into preparing that and presenting it to us this evening. Richard, next meeting, please.
Lost in HS2. Next meeting, we've got some people coming to tell us about rail monitoring and safety solutions. There's a company called Tech that's based down in somewhere in Kent, I think. Pretty well Kent. The lady called Liz Gray, who's an executive assistant to the chief executive officer of Tech, is going to come, and she's going to give us a really zany talk about modern monitoring systems, all the electronic means of doing it. I dare say it's going to involve things like drones as well. She's bringing lots of stuff, paperwork, to convince us all it's a good idea. Anyway, interesting company. Tech, there's a couple of people who are members of the PWI, I think, came to our meeting in January and said they'd like to do a talk. So we're getting a talk from that. I think it might be a bit of a commercial push, but we're all able to understand and appreciate that. But it'd be really interesting to see what's happening in another corner of the, the modern technical world. So that's next month on Wednesday, the 1st of May. That's it.
Okay, thank you, Richard. Just leaves me to say thank you to everyone in here for making the effort and coming along this evening. Thank you once again to Matthew for presenting this evening. It was very interesting.
And thanks to the people at home. We've had a good turnout at home as well. Thank you for tuning in, and we shall see you next month, same place, same time.
Thank you, Matthew. Thank you, Jeremy.
Thank you. Cheers, Ryan.
Yeah. See number online?
Yeah, so it was 10, possibly, but it's dropping off there. It was on by the way. So, yeah, but yeah.